Okay, what we're going to do is algebraic proof. Okay? And with an algebraic proof, we're just going to have things on our statements on the other side, our postulates, whatever we use. Okay? So, our first thing we do here is, in essence, in algebra, what I would do here is PEMDAS, right? Parentheses. Okay, take a look at that. They're done. 3x and minus 1, I can't do anything with that, right? Then I would go exponents. Well, there are none. So then I would move to multiplication division from left to right. Okay? Well, that's done, that's done. Oh, right here. Everybody on the block gets the paper. Half clamshell. Okay? Right? Kiko? What's this called? Everybody on the block gets the paper. Half clamshell. Close. Distributive. Good, Manny. Distributive property. Okay? Now, you can put it, distributive property is just there, D-I-S-T. You can write it out. Distributive property. Right? I don't do that usually. I just go done. Okay? I'm lazy. Math is for lazy people. We don't write the word 20. We write 20. Right? We're lazy. Okay? So everybody on the block gets a paper. I get 6x minus 2. Okay? Then I just do the next step. Change my color. Do the next step. So, multiplication division is done. So now I do addition and subtraction from left to right. So I am actually adding things up. So now I've got 3x and 20 minus 4 is... I am. I'm adding 20 plus negative 4. Or I'm subtracting. Either way. So what is that called when I do it just to one side? Just to one side. What do we call that? It's simplification, or just simplify. Simple. Okay? You're just simplifying. That's it. Okay? Change your color. Okay. Now, what I teach in algebra is after PEMDAS, we do what's called transition. You only see this on my YouTubes and in class because I made it up. What? So, transition. All I'm doing here is transitioning from PEMDAS to SADMAT. Okay? That's all. And so I had to come up with something, and what I do is I move the lowest variable by doing the opposite, the OPP. Okay? So, the lowest variable is 3, because 3 is lower than 6. I do the opposite of 3, that's minus 3. What I do to one side, I do to the other. That's minus 3x. And so what I get is 16 is equal to 3x minus 2. Right? Now, in algebra, that's called transition, or, simplifying. Right? But in geometry, we can't call it simplifying, because we're doing a property. We're doing something here. And what it is when we do it to both sides is it's called the, in this case, subtracting. So it's the subtraction property of equality. Okay? I'm doing it to both sides. I'm keeping the equation balanced. Okay? When you keep the equation balanced, it's of equality. So we have subtraction, addition, multiplication, division, property of equalities. Right? So that's what we did to do that. Right? Next step, change your color again. Okay? So I'm going to go back to purple. And now I go to SADMAP. SA. Okay? And in SADMAP, I start with SA and I say, what up SA? No. I say, what am I going to do? Subtract or add. Right? Whatever is subtracting or adding to the variable, I'm going to do the opposite. Okay? So since this is subtracting, I'm going to do the opposite. When I do to one side, I do to the other. Okay? And so I've got 18 equals 3x. Good. So DM, SADMAP, right? We very rarely get to the EP part. But we do the SA and the DM a lot. And this is, again, OPP. How can I explain it? Right? So, I got to do the opposite. Since this is timesing, I'm going to divide by 3. But when I do to one side, I do it to the other.
6x equals 3.
6 equals x. Oh, by the way, what did I do here in purple? I didn't write it. And you notice how I can go back up here and go, oh, wait a minute. I have a green, I have a red, I have the brown, but I don't have the purple. Bam, I grab my purple. Addition property of equality. Okay? Then I go to my brown, and I did division property of equality. Okay? And that's your algebraic proof. That's it. That's all there is to it. Okay?